नमस्ते चिल्ड्रन, आज हम बहुत इंपॉर्टेंट टॉपिक वेव ऑप्टिक्स जिस पर वेरी इंपॉर्टेंट क्वेश्चंस एट द सेम टाइम टफ क्वेश्चंस जिस पर बहुत इंटरेस्टिंग फॉर्मूलाज रहेंगे, ये हम देखेंगे। जरूर पूरा देखना एक दो बार और याद करना, ये बहुत यूज आ जाएंगे आपके एग्जाम्स पे। डू शेयर एंड लाइक. Children, let's do this important revision on wave optics with important tough MCQs, just 5 MCQs, but important formulas that you want to revise on. This is a question on Young's double slit experiment. A transparent sheet of refractive index mu and thickness T is placed in front of one slit. When you place that, what is going to happen? It is going to create a shift of the central bright image. So therefore, the central fringe is going to get shifted, and he says that it is shifted by one fringe with width, which means 1 beta. Okay, so you're going to equate two things. That is, one is the shift is equal to the width, which is equal to 1 beta. When you do that, you will get the thickness T in terms of lambda. So remember that the shift in the central, which is given by the formula mu minus 1 into T into d by d, whereas fringe width is beta is equal to lambda d by d, 1 beta. So when you equate that these two, you will get basically mu minus 1 into T is equal to lambda, because d by d will get cancelled, giving you T as equal to lambda by mu minus 1. Okay, so good question there. Remember that. Going to the next question on interference pattern. He says maximum intensity is 9 I naught, minimum intensity is I naught. The ratio of the amplitudes of the two waves. He's asking you the ratio of the amplitudes. You know that maximum I naught, intensity 9 is equal to 9 I naught, which is equal to root of I1 plus root of I2 the whole square. The same thing is nothing but A1 plus A2 the whole square, because intensity is directly proportional to A square, right? So therefore, you know these two things. So you can equate I max is equal to A1 plus A2 the whole square, which is equal to 9. I minimum is A1 minus A2 the whole square, which is equal to 1. Squaring both sides, you get A1 plus A2 is equal to 3, A1 minus A2 is equal to 1. Simple, solve that, you get 2 is to 1. So therefore, the ratio of amplitude is 2 is to 1. The ratio of intensities will become 4 is to 1 if I say intensity. The same question. The next question is on single slit diffraction. He says if the width of the slit is decreased, what will happen? Very simple. You know the width of the central slit is equal to 2 lambda by A. So therefore, if A is decreased, the central maximum becomes broader. Simple. Central width, angular width is 2 lambda by A, and so therefore the central width slit decreases, the diffraction becomes more, the central maximum will become broader. A telescope has an objective 10 centimeter and uses a wavelength of light 500. Two things are given here. He's asking you the minimal angular separation to say that the two stars are separate. For a telescope, remember resolution of a telescope. There is a formula for the resolution of the telescope and given by the Rayleigh criterion. And this is given by this very important formula. Theta is equal to 1.22 lambda by d. 1.22 lambda by d. 1.22 lambda by d. And so therefore, just substituting these two, you will get theta is equal to 6.1 into 10 to the power minus 6 radians. It's given in radians. When reflected and refracted rays are perpendicular, simple, the Brewster's angle. When the reflected and the refracted ray becomes perpendicular, therefore it basically gets polarized, which means that what? Tan of IB is equal to mu. The tan of IB is equal to mu. So that is what is basically says the Brewster's formula or Brewster's angle. And so that is what actually comes out with reflected light being completely plane polarized. I hope you like these questions because they were all tricky and needed it to be revised. Please log in and subscribe to RN NEET and do follow for more. Thank you.